Welcome to all. Now we are going to see about digital circuits. Digital circuit is nothing but it is an electronic circuit that processes digital signals which represents data as discrete values, typically binary, that is zeros and ones. It is nothing but we are going to perform the operations on digital signals, that is zeros and ones, so that we will get the corresponding output. These circuits form the basis of digital systems like computers, smartphones, and digital communication devices. Digital circuits use logical gates, flip-flops, and other components to perform operations such as computation, data storage, and data transfer. Unlike analog circuits, digital circuits are less susceptible to noise and signal degradations. So we prefer digital circuits over analog circuits. So these are the main characteristics of digital circuits. First one is precision, reliability, ability to handle complex tasks efficiently, and noise immunity. So here, the types of digital circuits are, first one is combinational circuits, second one is sequential circuits. Combinational circuit is nothing but it produces the output based upon the current input. So this one is called as combinational circuits. The second type is sequential circuits. The sequential circuits produces the outputs. So it is not only depends upon the present input, but the output is also depends upon the previous state's value. So these are the main difference between combinational circuits and sequential circuits. So based on the memory, the combinational circuits do not have memory. The output depends only on the current inputs. So we do not have memory to store the previous output values. Second one is sequential circuits. In sequential circuits, it will have memory to store the previous state values. Second one is components. So here we are using AND, OR, and NOT gate. In sequential circuits, along with this NAND, NOT, AND, OR gate, we are going to use flip-flops, latches, and registers. Based on the behavior, in combinational circuits, provide instantaneous output based on the input combination. So the output changes as soon as the input changes. In sequential circuits, have outputs that change in the response to inputs and this state of the memory elements. So the examples of combinational circuits are adder, multiplexer, and decoders. The examples of sequential circuits are counters, shift registers, and finite state machines. So in design complexity, generally simpler to design since they do not have required consideration of part states in combinational circuits. In sequential circuits, it is more complex to design due to the need to manage and synchronize state machines. So here the logic gates, these are the basic building block of the circuits. So the basic logic gates are AND gate, OR gate, and NOT gate. Then the universal gates. So NAND gate and NOR gate. So we can perform any operations, any task by using these NAND and NOR gates so that it is called as universal gates. Next, we are going to see about the basic gates. Then first one is AND gate. So AND gate performs the logical multiplication operations. Here we are using two input AND gates. The inputs are A and B. We are getting output, that is A dot B. This one is called as logical multiplications. So we are having the two input combinations, that 0 0, 0 1, 1 0, and 1 1. So this AND gate produces an output, that is when both the inputs are 1, at the time only it will produce the output 1. So if any one of the input is 0, we will get the output as 0. This is the main working of AND gate. So second one is OR gate. So OR gate is used to perform the logical addition operations. So here see the input combination 0 0, 0 1, 1 0, 1 1. So it produces the output as 0. When both the inputs are 0, only at the time only we are getting the output as 0. When any one of the input is 1, we will get the output 1. So this is the main operation of OR gate. Third one is NOT gate. We simply call it as an inverter. So it will produce the complement of your input. So if your input is 0, you will get the output as 1. If your input is 1, we will get 0. So in AND gate, it performs logical multiplication. When both the inputs are 1 only, we will get the output as 1. So second one is OR gate. It performs the logical addition operation. When any one of the input is 1, we will get the output 1. So third one is logical inverter. It produces the combination of NOT gate. Next, we are going to see about NAND gate. NAND gate is nothing but AND gate followed by an inverter is called as NAND gate. So it produces the output that is the complement of the AND gate. So this is the input combinations. When both the inputs are 1, at the time the output is 0. The remaining time we will get the output is 1. That is the complement of the AND gate output is called as NAND gate output. The second one is NOR gate. NOR gate means what? That is the complement of your AND gate. So here, when both the inputs are 0, at the time only we will get the output is 1. When any one of the input is 1, at the time we will get the output is 0. Next, XOR gate. So XOR gate, it is also called as exclusive OR gate. Here, these are the X and Y are inputs. So X exclusive Y. So here, see, when both the inputs are same, the output is 0. When any one of the input is different, so at that time the output is 1. So in simply it is called as XOR gate. See here, when both the inputs are same, that is 0, 0 and 1, 1, we will get the output is 0. If any one of the input is 1, we will get the output is 1. So next one is XNOR gate. So here, when both the inputs are 0, at that time input is 1. When both the inputs are 1, so here the output is 1. So we can simply call it as when both the inputs are same, at the time only we will get the output is 1. So by seeing this, we can easily say XNOR gate is the complement of XOR gate. In XOR gate, when both the inputs are same, the output is 0. In XNOR gate, when both the inputs are same, the output is 1. So the XNOR gate is also denoted as equivalence. So thank you for watching. In next video, we will see the types of combinational circuits.